This is a 7-color auto-blinking LED. First, I'll trim the negative pin of the LED to make it shorter. The next component I'll use is a BC547 transistor, which is a common NPN transistor widely used in switching and amplification circuits. I'll carefully bend its emitter and collector pins at a 90-degree angle to align them properly for soldering. Now, I'll apply some solder on the negative pin of the LED and the collector pin of the transistor. Then I'll solder them together, which creates the main path for current flow when the LED is powered. Next, I'll apply solder on the base pin of the transistor and the positive pin of the LED. Then I'll solder a 47 kilo-ohm resistor between the base pin of the transistor and the positive pin of the LED. This resistor is crucial because it limits the base current of the transistor, ensuring the LED and transistor don't burn out. Here I have an LDR, or light-dependent resistor. I'll solder it between the emitter pin and the base pin of the transistor. The LDR changes its resistance based on light intensity. In bright light, it has low resistance, and in darkness, its resistance increases. This is what will allow our circuit to respond to shadows or changes in light. After making all the connections, I'll remove the extra pin lengths using a cutter. This step not only makes the project neat, but also prevents any accidental shorts when the circuit is powered. Now, I'll apply solder to the positive pin of the LED and the emitter pin of the transistor to prepare them for the power supply connections. At last, I'll connect a 3.7-volt battery. The positive wire goes to the positive pin of the LED, and the negative wire goes to the emitter pin of the transistor. This provides the required voltage to run both the LED and transistor efficiently. Once the power is connected, the circuit is ready. When I place a shadow on the LDR, the 7-color auto-blinking LED starts glowing and blinking beautifully, automatically cycling through its colors. In the dark, the effect looks even more amazing because the colors stand out brightly. The transistor here acts as a switch. The LDR and resistor form a voltage divider that controls the base of the transistor. In bright light, the transistor is turned off, so the LED doesn't glow. But when it gets dark, or when a shadow falls on the LDR, its resistance increases, triggering the transistor to switch on and allowing current to flow through the LED. The LED then blinks and cycles colors automatically. You can use this LED as a night lamp that turns on automatically in the dark. In decoration projects where colorful LEDs add beauty, especially in dark rooms, for DIY toys or models that light up when covered, or as a learning project to understand how transistors and LDRs work together. This project is simple, fun, and a perfect way to learn the basics of electronics, transistors, and light sensors. If you try it yourself, you'll not only see a colorful LED glow, but also gain confidence in building your own circuits.